Welcome to the Planet of Maths channel. Today we're going to talk about properties of powers. It's a review of several properties of powers. Part 1 of the topic. The first series of examples involves multiplication or division of powers, where the bases are the same, but the exponents differ. Generally, the rule is that what is the same will also appear in the result. So if I have a 6 here and a 6 there, then a 6 will show up for me as well. So I'm definitely getting a 6. But to what power? In this case, when the bases are the same, the exponents are added. So here it will come out to 6 to the 5th power. With division, it's the same. If 9 repeats here and here, then in the result, that 9 will appear as well. And these exponents, 6 and 2, we just subtract, so here it will be 4. The result is 9 to the 4th power. Here we have division again, because a fraction bar is also division. 5 is here, and 5 is here. So 5 will definitely show up in the result as well. And since division is the same as in example B, we must these exponents 6 and 3, we need to subtract them. So here it will be 5 to the 3rd power. We subtracted 6 and 3. Example D, we have multiplication here. True, there's a fraction at the base, but here it is the same. So in the result, this fraction also has to appear. And what do we do with exponents? We do the same as in example A, which means we add, just like we added up there, here as well, 5 plus 3 equals 8. In this situation here, we add or subtract exponents when the bases of the powers are the same. The next series of examples are also multiplication and division of powers, but this time, what repeats is the blue part, the exponents. Here I have 4 and 4, here 8 and 8, and so on. So in such a situation, since there was a 4 here and there was a 4 there, thus a 4 must also appear in the result. So here we're going to have something to the 4th power. In this case, the bases are multiplied, 5 and 3 need to be multiplied. So here we will have 15 to the 4th power. That's the result. In the example F, we have division of powers. The exponent 8 repeats itself, it's here and there, so this 8 must also appear in the result. And what about the bases? We'll be dividing the bases just as the operation says. So 10 divided by 2 equals 5. In the example G, we have this same exponents again, which are these 3's. So this 3 also appears in the result. And with bases, we have to do what was done in example A. We've multiplied 5 by 3. These two numbers, 3.8 and 10, we also need to multiply. Just a little refresher on fractions here. Multiplying a decimal fraction by 10 involves moving decimal point one place to the right. Here we will get 38. 38 to the 3rd power. Example H is also a repetition of fractions, but first, the powers. 6 is here, and 6 is here. So 6 must also appear in the result, and we need to divide these two bases by each other. Dividing a decimal fraction by 10 involves moving the decimal points. Not like in the case of multiplying to the right, but when dividing, we move the decimal point one place to the left. So the decimal point will be here. After the decimal point, there must be 0.7. And we need to add the number 0 here. It'll be 0.07 to the 6th power. Be careful, because all these properties I've talked about so far, they work in the case of multiplication and division. In the case of adding and subtracting powers, it all doesn't work. So actions like here, even though I have 4's repeating here, I have 3's repeating here, the 7 repeats with another 7, and down here, 4 with another 4. These examples cannot be done, because all those properties only apply in the case of multiplication and division. The next series of examples are what we call power of a power. Almost all these examples are about powering a power, except for one, but more on that at the end. That means when we have the exponentiation of 4 to the power of 3 and then to the power of 2, the result will definitely feature the power of 4. And in this case, the exponents are multiplied, 3 and 2 need to be multiplied, so it comes out to 4 to the 6th power. In example Y, it is very similar. We have power of a power, but now the base is a fraction, but that changes nothing here. In the result, this 2/3, this fraction, it must also be found. We have here 2/3, and these exponents, 4 and 5, we must multiply together. Here it will come out as 20. 2/3 to the power of 20. In the next example, we have power of a power, and again, to the power. But if we have more of these powers, the rule doesn't change here either. The exponents just need to be multiplied. So the result will definitely include the base of 2. And here we multiply the exponents. 3 times 2 is 6, and times 4 gives us 24, which means 2 to the power of 24 here comes out. Example L is a bit different. because it doesn't have these brackets. So it's completely something else when we would have these brackets somewhere here. Such an example is no longer power of a power, but 2 is the base again, and so it appears in the result. And we then have to do what is here in the exponent of this number 2, which is 2 to the power of 3. We just have to carry out this operation step by step. 2 to the power of 3 is 2 times 2 times 2. So from this we get 8. Therefore the result here is 2 to the power of 8. And the last 4 examples in this video. In these examples, we'll practice what we talked about earlier. Example M is an example in which we have more operations to do than before. Such an example should be treated in a way that one looks separately at what is in the numerator and separately at what is in the denominator. These are to be 2 separate examples. At the top, we have here a 7 and 7 is repeated, so here it will also be 7, and we need to add the exponents 4 and 5. So the result is 7 to the power of 9. In the denominator, we have a power of power, so this 7 will be here too. You have to multiply the exponents here. That will make it 7 to the 8th power. And here it goes on this way. Now we'll turn on the numerator and the denominator. 7 to the power of 9 divided by 7 to the power of 8. The number 7 repeats, so the result will include 7. When you subtract 9 minus 8, that is 7 to the 1st power. And we could also say that it is 7. That's all in example M. Example N is a similar situation. Here too, we look at the numerator and denominator separately. In the numerator, we'll start with this. So I'll wait on it for now. I'll rewrite it. And if we calculate this, it's raising a power to a power. So from here I multiply 2 and 3. 4 of course doesn't change. And here it will be 6, because 2 times 3 equals 6. In such a situation, one must be careful not to multiply this 3 and that 3. We cannot do that first. You need to deal with the operation in the brackets first. That's the order of operations. I added a 1 here to make things easier, because without this one, it might be unclear what to do with these 4s. After adding this invisible one, we now know what to do, because this is multiplication of powers with the same bases, so here it will be 4. And you have to add 1 and 3 here, so it comes out to 4 to the 4th power, and this 3, you have to copy it here. So our example looks a bit better now, but it's still not quite right. We're now counting the numerator. Here we have 4, there we have 4, so it must be 4 as well. And these exponents will subtract from each other, resulting in 15. At the bottom here, it's a power of power, so the 4 remains, and these 4 and 3 are multiplied. And this is 4 to the power of 12. Now we have to divide the powers with the same basis, so the base 4 doesn't change. We need to subtract exponents. 15 minus 12 is 3. That is 4 to the 3rd power. And if we wanted to calculate it, it would come out as 64. Next example. Here we have division of powers. 4 here and here repeats, so we write 4. And 6 and 8, what we have to do with them? Since there's division here, we subtract 6 and 8. 6 minus 8 equals negative 2. And this is the result in the form of a power, and really, we should end here. But let's repeat how to do it with a negative power. Powering to a negative power means that you have to view the base of the power as a fraction. So 4 whole is 4 first. This minus causes the base to be flipped upside down. So instead of 4 firsts, we'll get 1/4, and that 1/4 has to be raised to the power that was here, just without that minus, so to the power of 2. And from this, we got result 1/16. The last example, here I wanted to point out this minus. It's a certain risk, one needs to be careful. Dividing powers, the bases are the same, so in the result, this 6 also has to appear here. And with these exponents, with this 2, and with this negative 1, what do I need to do? Well, I need to subtract them. So here I should do 2 minus this negative 1, so here it should look like this. And something like this, now I can skip these 2 minuses at once, and from these 2 minuses, I get a plus. So ultimately here it turns out to be 3. So the result is 6 raised to the 3rd power. And that's all for this video. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Mass channel.